Hi there. We looked today in class at 4.4b, which involved average value and second fundamental theorem of calculus. And so I've selected 3 problems similar to the ones you'll see on your homework to demonstrate what we learned. Okay, the first one here is number 50. Number 50, we are asked to find the average value of the function f of x equals 4 times the quantity of x squared plus 1 over x squared on the interval 1 to 3. Okay. Average value, the formula for average value is very similar to the fundamental theorem of calculus. It's 1 over b minus a times the integral from a to b of f of x dx. And the rationale behind this is that the integral from a to b of f of x dx calculates a total area, similar to calculating a total number of test scores in a class. And then this 1 over b minus a is dividing by the number of, for example, tests in the class, right? That's how you calculate an average. You add everything up and divide by how many there are. That's what this is, calculating the total, dividing by how many there are. Okay, so here we go. We have our function and our interval. We have the 1 over b minus a. This is my a, and this is my b in this equation. And then we have the integral from a to b of my function. Okay. And so then this fraction out front, which is 1/2, it's just going to hang out while we continue to work with our integral here, while we evaluate it using the fundamental theorem of calculus. Okay, so in order to be able to take the antiderivative, I do need to turn this into power rule, so I'm going to take a moment, I'm going to distribute that 4 in. I'm also going to rewrite this x squared in the bottom as x to the negative 2. Okay, so again, I distributed the 4 in, which gave me this 4x squared plus 4. I rewrote this x squared as x to the negative 2. So now I'm going to distribute in that x to the negative 2. At this point, we are in power rule form, so we can go ahead and take that antiderivative. The antiderivative of 4 is 4x, and the antiderivative of 4x to the negative 2, if we add 1 to the exponent and divide by that new exponent, okay, we get negative 4 over x from 1 to 3, right? Because negative 1 times 4 is that negative 4, and x to the negative 1 is over x. Okay, so now I'm going to go ahead and plug in my b minus plug in my a. We have 4 times 3, which is 12, minus 4/3, minus 4 times 1, which is 4, minus 4, which is 1/2 times 4 minus 4 is 0. And 12 minus 4/3, in order to do a whole number minus a fraction, we do have to find a common denominator here, which is 36 over 3, multiplying top and bottom by 3 to get that 36 over 3, which is 1/2. 36 minus 4 is 32, which gives me 32 over 6. 2 times 3 is 6, which reduces, 2 comes out of both of them, to 16 over 3. Okay, so that's average value. Okay, the other topic we looked at was second fundamental theorem of calculus, and I've picked 2 of those to demonstrate this thought process. Second fundamental theorem of calculus is when you're asked for a derivative. We were asked to find f prime of x with these ones. Okay? And when you're asked for the derivative, but when you're looking at your function, it's an integral, that's when you use your second fundamental theorem of calculus. That's your cue. I'm asked to take the derivative of an integral. Okay? And when that happens, the second fundamental theorem of calculus says I take my upper and I just drop it into this function. I'm not going to actually change the function in any way. I'm not going to take the antiderivative. I'm just going to put x in, which is my upper here. Okay, and so when I plug in that x, I get x squared over x squared plus 1. So I drop in that x into both of these t's. And then I times by the derivative of my upper, the derivative of that x, and the derivative of x is 1. Okay, minus, take my lower, drop it in, so we're at 1 squared over 1 squared plus 1, times the derivative of my lower, which the derivative of 1 is 0. So again, one more time, you drop in the upper, plug in the upper, times the derivative of the upper, minus, plug in the lower, times the derivative of the lower. Okay. And so then you get as an answer, this is something times 0, 1/2 more specifically, but something times 0, anything times 0 is 0, so that goes away. And x squared over x squared plus 1 times 1, it's just x squared over x squared plus 1. Okay. So one more to demonstrate that, because second fundamental is kind of the newest topic of this particular lesson. Okay, again, we were asked to find f prime of x. So we're asked to take a derivative, and when we look at the function we're trying to take the derivative of, we notice it's an integral. So when you're asked to take the derivative of an integral, it's second fundamental theorem of calculus. Okay, so I'm going to go ahead and take my upper here, and I'm going to plug it in. Okay. And so we have sine of x squared squared. Okay, and this extra squared, it's not something I've added in. It's here, right? This squared was located on that theta. So when I stick x squared into theta, this squared is going to stay as part of that problem. Okay, times the derivative of my upper. Derivative of x squared is 2x minus, plug in my lower, so sine of 0 squared, times the derivative of my lower, which the derivative of 0 is 0. Anything times 0 is 0, so that goes away, and we're left with 2x sine x squared squared is the same as x to the 4th. And there's your answer. Okay, so those were the topics we looked at in 4.4b.